Neutrons and hydrogen atoms are different versions of the same thing, or covalent bond between two hydrogen atoms is almost identical to a bond between a proton and a neutron. First compare. See drawing. Top, two protons and two electrons, or two hydrogen atoms. Bottom, two protons and one electron, one proton and one neutron. Background of my model. See other posts for details about quarks, masses, forces, etc. Proton is two positrons, E plus, and one electron, E minus. Neutron is two positrons, E plus, and two electrons, E minus. Proton is positron, positron, electron, or charge plus 1. Neutron is positron, positron, electron, electron, or charge 0. Neutron is proton plus electron. Covalent bond. We know that two hydrogen atoms, each made up of one proton and one electron, can share their electrons in a covalent bond. Further, both electrons in a covalent bond spend most of their time between the two protons, between the two nuclei. Their spin must be opposite. See top illustration. Suggestion that in my virtually identical model, a proton and a neutron, where the neutron is itself made up of a proton plus electron, can bond in the same way. Yet in my model, there is a difference. There is only one electron instead of two. That electron, like the covalent bond example, should spend most of its time between the two protons. So in the bottom illustration, the single electron from the neutron is mostly situated between the two protons. See bottom illustration. Further, we can now distinguish between a hydrogen atom and a neutron. The hydrogen atom has a single proton with an electron around it. The neutron, when connected to a proton, will have its electron caught between the two protons. When a neutron is free, it decays to a proton and electron in 10 to 15 minutes. So the difference between a hydrogen atom and a neutron is this. The hydrogen atom has a single electron circling it, while the neutron is a proton with a single electron circling it. But it can only exist when bonded to a proton. When it is by itself, it breaks down into a proton and electron. This suggests these discoveries. Hydrogen atom and neutron have the same exact makeup of one proton and one electron. The placement of the electron makes the difference. The missing antimatter is in protons and neutrons. The reason why the charge of a massive proton and tiny electron are exactly the same. The reason why a neutron and proton bond, or a deuteron, and why that is such a key aspect of the makeup of all atom nuclei.